If the first term of a GP is 1 and the sum of third and fifth term is 90, find the common ratio of the GP. Here we are given with A equals 1 and we want to find the value of R. And it is also given that the sum of third and fifth term is 90. We know the formula that nth term of a GP is given as A R raised to the power n minus 1. Therefore, the third term will be equal to A R raised to the power 3 minus 1, which is 2. Similarly, A5 will be equal to A R raised to the power 4. And it is given that the sum of these two, AR squared plus AR raised to the power 4, is equal to 90. We know the value of A, which is 1, so we can substitute A as 1. So we'll have R squared plus R raised to the power 4 is equal to 90, which can also be written as R to the power 4 plus R squared minus 90 equals 0. This is a biquadratic equation. In this equation, if we assume R squared equals X, that means R to the power 4 will be equal to X squared. So this equation can also be written as X squared plus X minus 90 equals 0. Now this is a quadratic equation which we can factorize. So factorizing X squared plus X minus 90 equals 0, we get X squared plus 10X minus 9X minus 90 equals 0, which will give us two factors, X plus 10 and X minus 9. From here, we'll get two values of X. When you equate X plus 10 equals 0, you get X as negative 10. Or when you compare X minus 9 equals 0, you get X equals 9. And X was equal to R square. That means R square is equal to negative 10 or R square is equal to 9. Now, square of any number cannot be negative. So that means this value is rejected. So we have R square equals 9, which gives us two values of R as plus or minus 3.